everyone. Today we will be doing the acidic atmosphere, and this is part of the acidic environment topic. In this section, we'll be mainly focusing on the gases that are in the atmosphere and how they affect the environment. Let's get started now. It says sulfur dioxide. Now, our atmosphere contains low concentrations of oxides of non-metallic elements. Now, oxides of non-metallic elements are oxides of those non-metals that are in the right-hand side of your periodic table. So, for example, carbon dioxide. Carbon is a non-metal, so the oxide of carbon is carbon dioxide, which makes carbon dioxide a non-metallic oxide. We'll be also looking at nitrogen dioxide and sulfur dioxide. So mainly we'll be focusing on oxides of nitrogen as well as sulfur dioxide in this section. These non-metallic oxides come from natural sources, but their concentrations have increased due to human activity, which means that sulfur dioxide and oxides of nitrogen do occur naturally, especially with volcanoes or even in hot springs. But human activities such as the combustion of fossil fuels have increased their existence. The Industrial Revolution is a big part of this. The Industrial Revolution had a major impact on these non-metallic oxide levels. There were major changes in agriculture, manufacturing, mining, transportation, and technology, having a profound effect on the social, economic, and cultural conditions of the times. Now, if you see, Industrial Revolution did make great changes, especially for agriculture, manufacturing, mining, transportation, and technology, making a greater effect on the social, economic, and cultural conditions. However, they did also pose environmental problems, especially the emission of sulfur dioxide into the atmosphere. Now, let's take a greater look into this. It began in northern England, then subsequently spread throughout Western Europe, North America, Japan, and eventually the world, which means that the Industrial Revolution now happens everywhere. So it is very industrialized now, which means that there's going to be more emissions of toxic gases. Some of the acidic oxides are responsible for acid rain, a serious form of air pollution affecting both natural and urban environments. Now, acid rain is rain that is quite acidic. That means it has a pH of less than 5, which means that like sulfurous acid and sulfuric acid is incorporated in the rain. Now, this rain does corrode marble statues and other forms of architecture, as well as plants and also water bodies, lowering their pH and affecting the animals that live in such water bodies. Sulfur dioxide properties, we'll be looking at a few properties, both good properties as well as bad properties. Now, it is an irritating gas with an acrid odour, which means that it is not a pleasant gas to have in excess in the environment. It is quite soluble in water, and this plays a big part for acid rain. Because it is soluble in water, it can dissolve with water to form acid rain. So around 9.4 grams of sulfur dissolves in water. So sulfur dioxide, as in 9.4 grams, dissolves in 100 milliliters of water, and this happens at 25 degrees Celsius. So this is a standard condition. However, it may differ as the temperature changes. Originates from many sources, both natural and man-made, and we'll be looking at this part in much greater detail later in the lesson. It's an irritant to the respiratory system, which means that it has health effects, and also it contributes to the diseases such as chronic bronchitis, which means that excess sulfur dioxide in the air may have health effects on organisms. But there are also useful properties of sulfur dioxide, mainly in the food industry, because it is used to preserve foods, especially manufactured meats, fruits and juices, as well as wine. Now, when sulfur dioxide reacts with water, sulfurous acid is produced, and this is when acid rain is happening. So we'll look at the word chemical equation now. So we have sulfur dioxide, which is in gaseous form because it's a gas. It would react with the water in the atmosphere. So there are water particles in the atmosphere, and this is in liquid form. Now this would give us sulfurous acid. Note, it is not sulfuric acid, it's sulfurous acid. So sulfurous acid is given by H2SO3, and it is in aqueous form. So this is how sulfurous acid is produced. Now again, we have to make sure that the equation is balanced. We'll start off with the hydrogens. There are 2 hydrogens on this side and there are 2 hydrogens on this side. So the hydrogens are balanced. Now moving on to the sulfur. There is 1 sulfur on this side and 1 sulfur on this side. So the sulfurs are balanced. Now moving on to the oxygen, we have 2 oxygens on this and 1 oxygen on this, which gives us a total of 3 oxygens. And we have 3 oxygens here, so that's balanced. So this chemical equation is already balanced, and we do not have to balance it furthermore. Now this also, sulfur dioxide also acts to prevent or retard bacterial and mold growth, which means it's used to further preserve foods. And also it's an antioxidant, and also an anti-browning agent. So clearly it's a very useful gas in the food industry. Now let's move on to the natural sources of sulfur dioxide. As I told you before, sulfur dioxide does exist in its natural form from natural resources. So for example, the combustion and decomposition of organic matter in bushfires. Now bushfires is a natural process. So when organic matter is combusted, sulfur dioxide is emitted. Also in the emission from volcanic activity, eruptions, geysers and hot springs. So these 3 things emit sulfur dioxide, and especially in quite large quantities. Now let's take some examples, specific examples, and these are very useful, especially if you're doing extended responses on such questions. If it's a 7 or an 8 marker, I would advise you to give examples so it's more detailed and gives a greater analysis. Now it is estimated that Mount Kilauea in Hawaii has released an average of about 350,000 tons of sulfur dioxide annually since 1986. Now that is a very great amount, and it happens annually, which means it's constantly occurring. If you take in 1991, Mount Pinatubo in the Philippines gave out 15 to 20 million tons of sulfur dioxide. So clearly they are huge amounts, and they are released naturally. When the gas comes into contact with water, an acidic solution of sulfurous or sulfuric acid is produced. Now we'll look at this in a more chemical based way. We have sulfur dioxide, that's our gas, and when it reacts with water, as it says, when it comes in contact with water, it reacts. So when it reacts with water, which is in liquid form, it produces sulfurous acid, and we just went through this a couple of slides ago. And we know that the equation is balanced because there are 2 hydrogens on this side, 2 hydrogens on this side, 1 sulfur, 3 oxygens and 3 oxygens. So this is how sulfurous acid is formed. But then also sulfuric acid can be formed. We know that sulfuric acid has the chemical equations H2SO4, not SO3. So now there are 2 ways that sulfuric acid can be formed from sulfur dioxide. We'll look at the first method. The first one is when sulfur dioxide from these volcanic eruptions comes in contact with the air and there's oxygen in there. So it reacts with the oxygen in the air to form sulfur trioxide. Sulfur trioxide is SO3, and it's also a gas. Now we have to balance the equation because it's not balanced. There is 1 sulfur on this side, there's 1 sulfur on this side. So the sulfurs are balanced. There's 2 oxygens here and 2 oxygens here, giving a total of 4 oxygens on this side. But there are only 3 oxygens on this side, so we have to balance the oxygens. To do that, you would first put a 2 in front of the SO3, which gives us a total of 6 oxygens on this side. So I would write 6O next to it for your working out. And we'd have 2 sulfurs here, so we have 2 sulfurs, but we only have 1 sulfur on this side. So the best thing to do is to balance the sulfurs again. So we would put a 2 in front of SO2, so which gives us 2 sulfurs here and 4 plus 2 oxygens, which is 6 oxygens on this side, and 2 times 3 is 6. We have 6 oxygens on this side. So now the word chemical equation is balanced. And what happens after this is a sulfur trioxide that is produced would react with the water in the atmosphere. So the sulfur trioxide gas produced reacts with the water, which is in liquid form, to produce sulfuric acid. So this is an acid and it's in aqueous form. Again, balancing our equation, we have 2 hydrogens, 2 hydrogens, 1 sulfur, 1 sulfur. We have a total of 4 oxygens on this side, and we have 4 oxygens on this side. So this chemical equation is balanced. And this is one method that sulfuric acid is produced. Now there is another method that sulfuric acid can be produced in, and that involves the same similar steps but uses different methods. So first we have sulfur dioxide, which is in gaseous form. Now this reacts with the water. So when it reacts with water, we know that it produces sulfurous acid. Now the sulfurous acid does not stay by itself. It would further react with the oxygen in the air. So the sulfurous acid reacts with the oxygen in the air, and this would produce sulfuric acid, which is H2SO4 in aqueous form. Now we have to balance the equation here. We have 2 hydrogens on both sides, so the hydrogens are balanced. We have 1 sulfur, 1 sulfur, the sulfurs are balanced. We have a total of 5 oxygens, 3 plus 2 is 5 oxygens on this side, but we only have 4 oxygens on this side. So to balance it, we would first put a 2 in front of this because we need more oxygens on this side. When we put a 2 in front of the H2SO4, we have 4 hydrogens on this side, 2 sulfurs and 8 oxygens. So we don't have 4 hydrogens and 2 sulfurs in this side, so we would put a 2 in front of here. So now let's see whether the equation is balanced. We have 4 hydrogens, 2 sulfurs, and also 2 times 3 is 6, plus the 2 here giving us 8 oxygens on this side. 2 times 4 gives us 8 oxygens on this side. So now the equation is balanced. And this is another method of producing sulfuric acid. So first it would react with the water to form sulfurous acid, and the sulfurous acid will react with the oxygen to form sulfuric acid. It's quite simple that way. Now let's move on to the human contributions of sulfur dioxide levels. Now humans generate significantly more sulfur dioxide than natural sources. Now that is alarming because we just saw that there are hundred thousands of sulfur dioxide emitted each year. Now humans generate significantly more than the natural sources. In the past, when emissions weren't closely monitored, so that was during the Industrial Revolution, especially at the beginning of it, many instances of dangerous, life-threatening and fatal levels of sulfur dioxide were released in urban areas. Now this was the beginning of the Industrial Revolution, when people were not aware of what was being emitted from coal burning, and sulfur dioxide was one of the gases being emitted. So a lot of life-threatening and fatal levels of sulfur dioxide were in the atmosphere, causing a lot of problems. Now one of these problems was the SO2 smog, the sulfur dioxide smog that happened in 1952. A mixture of sulfur dioxide from the power plants and heavy smoke from homes burning coal in fireplaces claimed 4,000 lives. So that really brought upon awareness of the sulfur dioxide emissions. These days, pollutant gases are more tightly monitored by regulatory bodies. So there are regulations and monitoring constantly happening to keep the sulfur dioxide levels in a safe and manageable way. These gases are spread across wider areas, so fatal concentrations of gases in densely populated areas are quite unlikely. Because they're gases, they tend to diffuse in and out, so they spread across a wider area. And they do not affect the densely populated area or urban areas where they're produced, but more the less populated areas. Sulfur dioxide is produced from human activities like energy generation and also metal ore refining. Now, energy generation is electricity from coal power, and also metal ore refining such as zinc sulfide ore refining. We'll look at it more carefully here. 90% of sulfur in the atmosphere comes from the burning of coal, because coal contains quite a lot of sulfur, and also the burning of fossil fuels. Currently, we produce about 50 to 60 million tons of sulfur dioxide per year, so that's quite a large amount. Impurities in petroleum are mostly sulfur-containing organic compounds. In coal, they are mostly present as pyrites, in particular iron pyrites. So for example, we have FeS2, which has sulfur in it. So when it undergoes combustion, this sulfur would produce sulfur dioxide. When fuels are burnt to produce energy, the sulfur impurities are also burned to oxidize to sulfur dioxide. Now let's look at this in a chemical equation form. We have the pyrite combusting, so it's reacting with oxygen in the presence of heat to give us F2O3 and also sulfur dioxide. So you can clearly see that this sulfur dioxide is being produced. So this is when coal is burning, so sulfur dioxide is being produced as a result. Now let's take another example. In Australia, the combustion of coal provides about 70% of all electricity supplies, which means that we need quite a lot of coal burning. That means more emitting of sulfur dioxide. So sulfur dioxide emission is therefore a concern because we do emit a lot of sulfur dioxide into the atmosphere. Sulfur dioxide is also released when natural sulfide ores in various metals such as iron, copper and zinc are roasted or smelted as part of the refining process to obtain the metal oxide or the free metal. So we looked at how we would smelt different ores to get the metal. If we smelt, for example, iron sulfide or zinc sulfide, we would get the zinc oxide as well as sulfur dioxide. So for example, zinc sulfide reacting with oxygen, this is a combustion reaction under the presence of heat, giving us zinc oxide and sulfur dioxide. Again, you see the production of sulfur dioxide. And this happens quite often because we do require metals and they're extracted from the ores quite often in a regular manner. In New South Wales, we are fortunate because the coal mined here have a low sulfur content. What that means is that the sulfur content here in our coal is lower. Again, meaning less sulfur dioxide produced as a result. But we are a major refiner of the sulfide ores. So we do refine copper sulfide, zinc sulfide and lead sulfide, emitting sulfur dioxide into the atmosphere. The formation of acidic substances from sulfur dioxide. Now we'll be looking at how acidic substances as well as acid rain is formed from sulfur dioxide. Once in the atmosphere, sulfur dioxide can be oxidized. We looked at this in a previous slide when we saw it reacting with oxygen to give sulfur trioxide. Well, we'll be looking at it again because this is a process of acid rain production by either oxygen or ozone. So ozone is given by O3. So sulfur dioxide can either react with ozone or oxygen to form sulfur trioxide. See here, it's reacting with oxygen. So sulfur dioxide with oxygen gives us sulfur trioxide. And again, balance the equation and write the states, very important. or it could react with the ozone. So we have sulfur dioxide reacting with ozone to produce sulfur trioxide and oxygen. Now, sulfur trioxide is also an irritating gas and induces choking sensations, which means that it should not be around in excess amounts. In the atmosphere, both sulfur dioxide and sulfur trioxide react with water when it rains to form acids. So if sulfur dioxide reacts with water, it forms sulfurous acid. As you can see here, H2SO3. Or sulfur trioxide could react with water to form sulfuric acid, which is H2SO3. And the sulfuric acid here would ionize to form a H plus ion, which is proton, and the HSO4 ion, which is the hydrogen sulfate ion. Sulfurous acid, which is H2SO3 in aqueous form, is a weak acid, but it is more acidic than carbonic acid and ethanoic acid, contributing largely to acid rain. So acid rain is mainly made up of sulfurous acid, which is a weak acid. Sulfuric acid, which is H2SO4, is a much stronger acid, and it is also a diprotic acid in the sense it has two hydrogens, further making the problem worse. So now we came to the end of the lesson, this section. We looked at sulfur dioxide and the presence of sulfur dioxide in the atmosphere, and also how it is used, as well as how it is produced both from natural sources as well as human man-made sources. Now we'll look at a few questions that might be from this section. So question 1, which is a multiple choice question. Which of the following is not an artificial source of sulfur dioxide? Now we have 4 options here. We'll go one by one. So option A, smelting. Smelting of sulfide ores is an artificial source of sulfur dioxide, because artificial source means man-made source and smelting is a man-made source. So that is not correct. We'll go to option C now, combustion of fuels in vehicles. Combustion of fossil fuels is again an artificial source. It is due to man's production that combustion of fossil fuels happens in vehicles. So option C is not an answer. Note that it is not an artificial source. So it is best to underline keywords such as not to make sure that you do answer it correctly. Option D, electrical power plants. Electrical power plants are again human productions. So option D is not the correct answer. Option B, lightning. Lightning is a natural source because lightning happens naturally, where the heat from the lightning catalyzes a reaction between sulfur and oxygen, producing sulfur dioxide. So clearly, lightning is the answer for question 1. So B is the answer. Now let's move on to question 2. It says, which of the following is incorrect about the formation of acidic substances in the atmosphere? As you can see, incorrect is bolded here, but it not be necessarily in your HSC paper. So if you see some keyword like this, incorrect, you should highlight it so you know that you're answering it correctly instead of picking the correct answer instead of the incorrect answer. So we have 4 options here again. We have option A, sulfur dioxide can further oxidize to sulfur trioxide. When sulfur dioxide reacts with oxygen, it does produce sulfur trioxide, which means that this is a correct answer. It's true factually, but this says for an incorrect answer. So this is not the answer. Option B, sulfur dioxide reacts with water to produce sulfurous acid. Again, we did do this before, where sulfur dioxide reacts with water and that produces sulfurous acid. So this is a correct answer and it is factually correct, which means it's not the answer for this question because this is incorrect. So B is not the answer. Now let's look at option C. Option C says sulfur trioxide reacts with water to form sulfuric acid. Now that is true because sulfur trioxide with water does form sulfuric acid, which means that it is factually correct, meaning that is incorrect for the answer. So option C is not the answer. Now let's consider option D. Sulfuric acid can easily decompose to produce less acidic sulfurous acid. Now that is not true because sulfuric acid cannot easily decompose to form sulfurous acid. Therefore, option D is incorrect, making it correct for this question because it's asking for the incorrect answer. So option D is the answer. Now let's move on to question 3 now. Question 3 asks, important natural sources of sulfur dioxide are. We have 4 options here and it says natural sources, which means that it's not man-made sources. We'll consider option B first, metal smelters. Metal smelters are not natural sources of sulfur dioxide. Even though metal smelters do produce sulfur dioxide, it is a man-made source. Option C, asthma attacks. Asthma attacks is a health defect due to the presence of sulfur dioxide, and it is not a natural source of sulfur dioxide. So option C is not the answer. Option D, motor vehicles. Motor vehicles are not natural sources of sulfur dioxide, which means that it is option D is not the answer. Option A, bushfires and volcanoes. Now bushfires and volcanoes are natural sources and they do produce sulfur dioxide, making option A the correct answer. So option A is the correct answer. Now let's move on to question 4. Question 4 asks, describe using equations examples of chemical reactions which release sulfur dioxide. Now these can come as either extended response questions in your HSC or short answer questions, which means that it does require a lot of detail. One, it says describe, which means that you have to give a very detailed answer. Also, it says using equations, which means you have to provide more than one equation to get full marks, because usually one equation gives you 1 mark or 2 equations give you 1 mark. So you have to provide more than one equation. So here it says the main contributor to high sulfur dioxide levels is the combustion of fossil fuels in power plants and vehicles. So here we have provided a little explanation of what are the contributors of sulfur dioxide. Coal and petroleum products contain sulfur, so we have given more detail in the answer, which combines with oxygen to form sulfur dioxide. Now here you should include an equation for this one. So your equation would look like this. When you're writing equations, always balance your equations and also write the states, because that is part of the equation and you would not get marks if you don't balance it and write states. The smelting of metal sulfides such as copper sulfide also produces sulfur dioxide. Now this is giving more than one example. Again, you would use an equation for this. Again, I would strongly advise you to balance your equation and write the states down, because that's part of writing an equation. So to obtain full marks, you would have to provide more than one equation, because it says equations. Now let's move on to question 5. Question 5 is, describe the major sources of sulfur dioxide in the atmosphere under the headings natural sources and sources due to human activities. You could either do this in a table or dot point form under each heading. So this answer is written in dot point form under each heading. Natural sources is the first heading. So we would first list the natural sources of sulfur dioxide. So bacteria decomposing organic matter to make hydrogen sulfide. Volcanic gases, bushfire smoke. Now the sources due to human activity. Burning of fossil fuels, smelting of sulfide ores such as copper, FeS2 and also zinc sulfide. So this is how you would go about answering the question. You could also do this in a table form. It is up to your choice and also the available time you have in your exam. So that brings us to the end of the section. We covered sulfur dioxide, the production, natural sources as well as man-made sources, as well as how it is useful, and also the disadvantages of having excess sulfur dioxide in the atmosphere.